Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Differentiate the following: y equal to e to the power root x, right? So our basic function out here is e to the power x, right? And instead of x, we have square root of x, right? Which means this is a function of the type y equals f of g of x, right? Right, and then I'm going to put up the chain rule, which is what we will be using to solve this particular problem, or the composite rule in differentiation. So let y equals f of u be a function of u, and in turn let u equals g of x be a function of x, so that y equals f of g of x. Then dy by dx equals dy dx of f of g of x equal to f dash of g of x, which means my f dash is with respect to g of x into g dash of x, which is with respect to x, right? So what is my u here, right? My u is nothing but root x, right? So let's do that substitution. U equals root x. I can write my u as, how do we write this? U equals x to the power half, right? That's nothing but our square root, folks. So let me write that. So becomes equals x to the power half, and therefore what is my du by dx? By du by dx, again I use the formula, and this time I'm not going to write it on this. My du by dx of x to the power half is nothing but half into x to the power half minus 1, right? X to the power half minus 1. And what is my half minus 1? Which is a minus half. And what is that? I have it as 1 by 2 into x to the power minus half, means my x to the power minus half can be written as 1 by x to the power half, right? So what is that? It is nothing but 1 by 2 root x, right? And this is again a very useful formula to remember. We are using the identity that we learned earlier: d by dx of x to the power n equals n into x to the power n minus 1, and that is the particular formula that we apply here. So let's go back. We have our du by dx now. I'm going to go and do the substitution of y in terms of u, right? So what is that? So my y equals e to the power u. Why is that? Because we have done the substitution of u equals root x, right? Now I know what is my dy by du, right? My dy by du is very simple. We have worked this out earlier using first principles, and request you to take a look at my video. I will put a link to that particular video in my description. So my dy by du of e to the power u is nothing but e to the power u, right? So let's copy that. And now I have my dy by du, I have my du by dx. We've been asked to find dy by dx, and what is that? My dy by dx is nothing but dy by du into du by dx, right? And what is my dy by du? It is nothing but e to the power u. And what is my, it's coming from this expression. Let me highlight it in green, right? So this is my expression. And then my du by dx is what I calculated earlier. Let me call it in yellow. I go back and I pick this up from here, which is nothing but my 1 by 2 root x, right? So I have my answer but I have the expression in terms of u and x, right? So I will have to go back and do the substitution of u equals root x so that I express everything in the form of x, right? So my e to the power u becomes e to the power root x, and then I have my 1 by 2 root x here with me, which means I have arrived at my final answer, which is nothing but e to the power root x into 1 by 2 root x, right? Again, an application of the chain rule. So what are we actually doing here? When y equals e to the power root x, I differentiate the e function, the e power function with respect to root x, right? So I just write it as it is. Why is that? Because my dy dx of e to the power x is always e to the power x, right? So I write my e to the power root x, that is my first part of the answer, and then I go ahead and then pick up the inner function, which is my g of x, which in this case is root x, and then I do a differentiation of root x, which is nothing but 1 by 2 root x, right? As that is how we arrive at the answer by method of substitution. So e to the power root x into 1 by 2 root x is our final answer. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.